Hi everyone, welcome to the first video on our DXO project. If you're just joining us, we're right at the beginning of a collaborative design project for a steel enduro frame. The initial frame will be designed with input from as many people as possible and made by me in my little workshop here. My goal is to make all data, drawings and files available open source and to come up with a frame that's not only sick to ride, but is also relatively simple to fabricate so that we can get more riders making their own frames. I'll talk more about that as the project progresses, but for now, we need to start discussing some of the key points of our frame design. So let's get into it. So we need to dial in our suspension design. I think there might be a common belief that more complex suspension designs are better than simpler ones, and it's not necessarily true. Simpler designs just require all aspects of the design to be balanced in exactly the same way as geometry. Each element affects the next. And that balancing act is what makes these designs so cool and fun to work on. Obviously, a simpler design has benefits to the rider too. Low maintenance being a big one, fewer bearings, etc., easier to clean. They're also usually lighter because there's just less going on, which benefits the rider and the designer, because as the designer, we don't have to count the grams in more critical areas of the frame. So our DXO frame is a linkage-driven single pivot frame. I've roughed out a layout to get us moving, but I'm happy to flip the whole thing upside down if that's what the community decides. But a linkage-driven single pivot fits the bill perfectly here. The first thing we need to figure out is the anti-squat behaviour of our DXO frame. On our frame, this will largely be determined by the main pivot location. What is anti-squat? Well, let's first talk about squat. Squat is a rearward load transfer under acceleration. So as you pedal, load is shifted to the rear contact patch and will also compress the rear suspension. We want to counteract that to improve chassis stability, for grip, handling, and to maintain geometry. So we achieve anti-squat by using the drive chain to actually extend the suspension as we pedal, and that opposes the squat induced by acceleration. Since we can't really move the drive chain, we move the suspension points around it, in our case the main pivot. There's a pretty straightforward way to calculate this, which gives us a percentage of anti-squat. So 100% is like equilibrium. All of the squat forces are cancelled out by anti-squat, at least that's the theory. Some designs come in a little over 100, some are under. Traditionally, some brands have been known for efficient designs with anti-squat over 100%, and others have swayed more towards active designs with less than 100%. You might say, well, 100% sounds good, why don't we just do that? Well, we could, and maybe we will, but let me try and explain why we might not. Okay, so my T16 here is intended to be a true all-round trail bike, and I tune the anti-squat slightly on the higher side. It's designed to cover ground in rolling terrain and really rewards the rider that's pushing on. The flip of that is that in slower, chunkier terrain, each time you hit a bump, part of your pedal stroke goes back into extending the suspension again. But the T16 is a shorter travel machine with a good leverage curve and a shorter sag range, so we can use a nice firm pedaling platform. Any issues related to anti-squat are at a minimum here, and crucially, a climb switch is absolutely not necessary. But our DXO frame is going to have more travel, more sag, it'll probably have burlier tyres fitted and probably be trucking through chunkier terrain at slower speeds than the T16. For a bike like the DXO, active suspension can actually be more efficient, allowing the rear wheel to track the ground while you spin away on the pedals. And the flip of that is you might experience some squat on smoother climbs and short, sharp maneuvers where a climb switch can definitely be helpful. So this whole thing can pretty much be simplified down to whether you think climbing switches are a crutch for a poor design or a tool to be used to increase versatility. And quickly, before we wrap up, the elephant in the room, pedal kickback. Designs with more pedaling induced anti-squat have more kickback, and that will be the case with the DXO. So another important thing to consider is whether we're okay with that. Do we go with a higher anti-squat and maybe use something like an O-chain to compensate? Or do we just keep everything active and run an unadulterated drive chain? Or do we play it safe and send it straight down the main line with confidence and keep things in the middle? So let me know what you think in the poll below, or if you're watching on YouTube, just smash that like and subscribe thing. Hit the comments wherever you're seeing this, and maybe we can get into some of the finer details. It'd be great to hear what you think. Now, I talked a lot here in this video, but as the project progresses, things will get more hands-on and more exciting, and hopefully you'll be able to see me actually make the DXO frame towards the end of summer. Cheers, folks!